Hello friends, today I'm going to talk about Leetcode 1049, last stone weight 2. The problem is that we have a collection of rocks. Each rock has a positive integer weight. Each turn you choose any two rocks and smash them together. Suppose the stone have weights x and y. If x equal to y, the stones are totally destroyed. If the x is not equal y, you will choose the minimum difference of the x and y and keep the difference of the x and y as a new stone. In the end, you have at most one stone left. The problem is to return the smallest possible weight of this stone. And this example here, we have these 6 numbers, and after we smash 2 and 4, we get a new stone 2. There is a difference of 4 and 2, and then we smash 7, 8, we get this number. Then we smash 2, 1, we get 1, 1. Then finally we get the 1 here. And this problem is actually an extension of the first last stone weight problem. In the last problem, we use the greedy algorithm to pick two heaviest stone first. In this problem, it does not work again. Here we can pick any two stones. And here is actually we have to consider that use dynamic programming here, because after every time you pick a problem, pick two stones, and whether the rest of the stone will be a sub problem to solve it. Assume we have the A and B and C and D. So we have many options to pick stones. So one option is that we pick A first and then pick B. We get a new stones of the A minus B or B minus 1. Assume A bigger and equal to B. And then the second step is that we could pick C and D first. And we get C minus D if C bigger than D. And finally, the step, so we have the A minus B and also minus C minus D. So actually we find that we can transfer to A plus D minus B plus C. So here we find that we could transfer to, this is a set S1, this is another set S2. So it seems that we could find two sets, that is the difference. We will try to get the minimum difference of the two sets. Is this really the case? If we consider other options to pick, for example, use the second option to pick. If we pick A first and then pick AB first, we get the A minus B. Then we pick C here, so we get pick C, and with A minus B we get A minus B minus C. If A minus B is bigger than C, we get a new stone. And then we pick D, we get A minus B minus C minus D. And this could also transfer to A minus B plus C plus D. Also, this is also one set here, S1, and this is another set, S2. So no matter which way we pick, actually we can always get us two sets. So this problem is that we find the minimum minimize of the two sets S1 minus S2. And also we have another condition that is S1 plus S2 equal to sum of the array. So it reminds me of the subset problem. The subset problem is try to find whether there is a subset or find the subset that has the target in the num. So for this subset problem, it will also NP complete problem. For the decision problem, if there is a subset equal to target, we could use a dynamic program to solve it. So we could define a DPI and this S is as if it's true, if only if there exists a subset sum equal to S from index 0 up to index I. So and for here is I should be the bigger than 1, less than n, and also 0 should be smaller than S should be smaller than sum of the stones. So it's also similar to the 0,1 knapsack problem. So we could solve this problem with O n times the sum of the num, n is the length of the num array, and of course we could reduce to the O(n) time, but here it is easy to come up with O(n) times some num for this subset problem or the zero knapsack problem. After we find if there is a subset for every subset for the S, because S is between 0 and sum, so we will have to because we want to find the smallest of this difference. So we actually the mean S1 S2 with and also S1 plus S2 equal to sum of the num. We will have to find the difference, so we can get the if we set S1 minus S2 equal the answer we want to get. So we can refer that answer is equal to 2 times S1 minus sum, or answer equal to sum minus 2 times S2 here. So when we try to minimize S1 S2 S1 minus S2, that is equal to we want to maximize we want to maximize S2. If S2 is maximized, then this answer should be S1 minus S2 is minimized. So let's consider the transition factor. The The transaction function is like the left save function here. That is, is should equal to the dpi minus 1. As if the current stone is not selected, or if the current stone is selected. So we have to minus the stone's current weight. If the stone current weight is smaller than the current target s. This is basically this is the transition function here. Let me add the code. Here we define the sum equal to sum stones s2 equal to 0 and the next stones. We define the that is the initialize the dp array here. And we make some initialization here. If the target sum is 0, we could set it there always array that is stored that could satisfy for the target 0. Then we so if the stone is smaller than this, then the I minus 1, we could we will discard the current stone, only get from the previous stone. Otherwise, we will fetch the current stone. And if the current sum s is satisfied, then to only we update the maximum subset for s2, because we want to return the sum of minus. It should be the minus sign minus. So 2 times s2 here. And actually, that is, we do not need to consider the sum here. We need to only consider sums of 2, because the two subset, the maximum target is only the half. If one could be the difference, there's always be the always one is smaller or one is half, or both are equal. So we only need to get the target sum equal to 2 here. And here we can also have sum 2 here, a half here. So let me run the code. Okay, oh my goodness. Okay, let me run submit. Okay, we made it.